All right, here's our bell work. 1, 2, 3, 4, 5. 5 questions. 3 is interesting because it just wants x, not the value of those angles. But you could find them after you find x, though. So just based on what we learned last time, complementary, that's 90-degree angle. So it would be 90 minus 3, that's the 87 degrees. That's the measure of angle A. 2 adjacent angles should look something like this. I mean, you can have a line like this. You could have 2 lines. You could even have 3, but one doesn't have to be connected. Any 2 that are right next to each other, like this purple and this red one. That would work. Looks like x is 7, and the relationship between angles in number 3, those are vertical angles, it's true. And what's the measure? Oh, we got the measure of those angles as well, 23 degrees. All right, here's our objective for today. I can identify special angle relationships formed by transversals. I think we're going to be looking at solving for them as well, but we'll just put this down for now. So a transversal, that'd be like a line, by the way. A transversal line is a line that goes through 2 or more other lines. Like this line T right here, I'd be looking at T for transversal. It's going through lines L and M. Now last time when we talked about vertexes or vertices, it's like corners or intersections of lines. Those we usually use capital letters. To indicate that we're talking about lines, we usually use lowercase letters, like we see in this case with T, L, and M. So we'd say T is a transversal with lines L and M. It is possible you could say that L is a transversal between lines T and M, or that line M is a transversal with L and T. Now the only thing we need to understand about transversals is that it can't go through. A transversal line cannot go through 2 other lines at the same point, okay? So let me give you an example here, right? We got, let's say we got this line, and then we got this line right here, I know, A and B. And let's say that we had a third line that goes through these ones, right? We'll say this is line C right here. Well, you couldn't say that any of these are transversals because it's going through the other 2 lines at the same point right there. It's got to go through the 2 lines at different points, like we see with this example that was given with lines L and M, T, the transversal. It's going through L and M through 2 different points. It can't go through them at the same point. So to find transversal in your own words, draw another transversal for 2 lines above. Yeah, we'll do that. It said to label it line R. This is the one that I drew. You didn't have to draw this exact one, but that's the one that I drew. Some students like to put it over here. It's up to you, whatever. Okay, but I put it on the left. Just here's what you cannot do, right? You cannot put this line through this order or this set right here with lines T and L, I guess. I mean, it would still be a transversal with lines T and M, but not T and L. Be careful on that stuff. Yeah, it cannot go through the 2 lines at the same point. Yeah, that's a big deal. Yeah, so a transversal is a line that intersects 2 or more other lines at different points. Remember that last part. Sometimes we get that last part confused. It has to be at different points. Right here, we could say that line R is a transversal with line T, even though it's not showing that intersection, right? Like this intersection between R and T would probably happen up somewhere up here, right? So even though it doesn't show the intersection, they may still intersect at a different point somewhere, which then would make it a transversal. And we know this one, both lines continue because they gave us the 2 arrows on those 2 lines. L would be a transversal with lines T and M, right? Because it would go through line T here. And again, it's not showing the intersection with lines L and M, but we know it would happen maybe somewhere back here. So that would be like 2 different points that L goes through lines T and M, which makes it a transversal with those 2. Right now, the only thing we want you to understand is what a transversal line is, because we're going to use that terminology a lot, not only in this section, but in this unit. We'll say transversal line, transversal line. It's important that you know what it is. It's just a line that goes through 2 other lines, but at different points. And so here's more transversal stuff, right? We're looking at line A's, B, C, and E. That's parts A, B, C, and D. But we just want to see what other lines, for example, line A is a transversal with, right? So we'd be looking at line A, that's this one. Now again, even though it's not showing the intersections, the exact intersections, there are other intersections with line A, right? Because the only one it's showing right here is line A intersecting with line D. It's going through line D, but it does go through some other lines. Now, if we looked at this, it's important to notice that lines A and B, they appear to be parallel. So I'm going to make that assumption that lines A and B are parallel. They didn't say they were, but visually I'd say, hey, these two look like they're parallel. In fact, C and F, lines C and F look parallel as well. And same with lines D and E. Now that's important when we consider if one is a transversal of another, because parallel lines can't be transversals with each other because they'll never cross through each other, okay? So if I listed all the lines that line A is a transversal with, and of course you'd be looking at two sets, right? You'd have to have two lines each, so you'd say something like it definitely goes through D, and it looks like it goes through C as well, right? Or you could say that line A goes through line F, and eventually it would go through line C. Or maybe line A, yeah, it definitely goes through line D still, but E as well, right? It'll eventually go through line E. Okay, now that's just a few sets. I'll show you all the sets here in just a moment. Line B, okay, so that's this one. It looks like it's parallel with line A, so I'm not going to list A as one of its transversals with. So line B, it definitely goes through line C. Now I cannot combine line B as a transversal with lines C and D, right? Because it looks like it's going through the same point. So you would not put a D right there. You cannot do that because it's at the same point. But what you could do is say, well, line B goes through line C and E at different points though. There we go. Or line B, it'll eventually go through line F. And it looks like it goes through line E as well at the same time. Not at the same point, but eventually at the same, well, I'm not going to see the same time. That sounds weird. Now it does go through line D though as well, and you could say line E. Now you say, some students ask at this point, well, line D and E are parallel. That's true. We're not asking if D is a transversal with E. We're saying line B is a transversal with D and E, which is a little different on that, okay? So that means you could take two other lines, like line C and line F, which are parallel. Line B will eventually, it's showing that it goes through line C, but it will eventually go through line F as well. So line C, that's this vertical line right here. Yeah, you can see it's going through line B, and eventually it would go through line A. So that's a good one. I can see that line C, it's going through lines D and E as well. And yeah, we see that set was with line B. That's okay. We're just considering if line C goes through D and E right there and there. So what other two? Let's do one more. C, it'll definitely go through line A. And we already see that it's going through line E. So that's a good one. And yeah, my handwriting, maybe it should be better. But line E, that's this horizontal one right here. Yeah, I can see it goes through line B. And it also goes through line C in different places. Yeah, so if you wanted to list A and B, you could. Or if you wanted to list F and C, that would work. Of course, there's a lot more, but this one we just wanted to look at least two. So here's all of them. I know some of you were interested in all of them, but that was a lot of writing. So I just kind of copied and pasted that garbage. So going back to line B, right? So line B, I'm gonna try to copy this down. So I'm just putting them separately. So even though it's showing all the lines, sometimes it's easier mentally to just draw these separately. So when I draw line B, I can see it's going through, this would have been line D right there, and line E right here, right? Which is why it still is a transversal with line D and E, because it's going through this point and this point. So I'm ignoring, pretty much just ignored line C, right? Which would have been right here, and would have gone through this point. But when I look at B as a transversal, I only need to look at 2 lines at a time. So right here, when I look at, is line B a transversal with D and E, I'm ignoring C, and so it would redraw the diagram like this. So yeah, it still is a transversal there. So if you look at a map, right, of streets, particularly in Utah where we use the grid system most of the time, there's a lot of transversal streets with other streets. But once you start considering intersections like this, okay, then they're not transversals with each other. I don't know if that helps or makes it worse, but I gave it a shot. All right, here's some more vocabulary. We got interior, which is usually that's considered on the inside. Exterior is considered outside. Corresponding means that they're in the same location. It's just like when it says matching, it just means they're in the same position at different vertices, okay? And then we got straight angles, angles that are, we've seen those before, they just make up a straight line, right? So when you combine those 2 angles, it's a straight angle. So if I looked at some of this vocabulary that they give us, you got alternate exterior angles, okay? So first of all, let's identify in this chart what is exterior and what's interior. So I kind of look at this like a sandwich. Maybe I like sandwiches more than I should. But considering my size, maybe I don't like them as much as I should. Anyways, I'd say this is like a sandwich right here, right? So I'd say this is the inside of the sandwich. This is kind of like the outside of the sandwich. And of course there's bacon on it, yeah. Yes. Of course. And this, I don't know why you do this, but some people I've seen, they put toothpicks in their sandwiches. Not me. But it can be, yeah, sure, I know, but my hands will make sure that it doesn't fall apart. And if it does, I'm still okay with it. In any case, I would say that this is the inside, or more specifically for our vocabulary here, this is our interior. I feel like I spelled that wrong, but it looks okay. And then you got 2 parts that are exterior on the outside, right? So this is considered exterior. And this also is considered exterior. Now, once we understand interior and exterior, placing alternate parts of exterior or interior, it should help, okay? So, exterior. So, alternate exterior. We're looking at these in pairs, by the way. They should just be in pairs. So I'm going to take alternate exterior angles here. And I can just say it's this angle right here for now. So that's blue right there, right? Now for it to be alternate exterior angle, it has to be at a different vertex or intersection, but on a different side as well. So that means that I would have to take this one. And copy. I didn't copy. I'd have to take my alternate exterior angles, and I know it's got to be at one of these 2 angles right here. But since it's alternating, it's got to be on a different side right there. So that would be this angle. This angle, these 2 angles in blue that I've marked are alternate exterior angles, which also means that the other angles, this one and this one, are also alternate exterior. So those are alternate exterior angles. So next up is corresponding angles. Now, corresponding says it's at the same location, but it should specify this. It's at the same location, but a different intersection, okay? So if I looked at corresponding angles, let's see if we can do this, okay? So I'd look at this angle right here. I'll mark it. Boom, this one, okay? So that's corresponding. Now, I would look at the intersection. It's related to this intersection here. I'd say that's top left for me. So that means I'd have to take the other top left angle, and yes, I've already marked it in blue. I'll mark it again in purple here. But this also would be considered its corresponding angle here as well, okay? So those 2 are considered corresponding. They're the same, they're different intersections, but the same place of those different intersections. Yep, so yeah, I like the way that's worded. They're corresponding to each other. And of course, there's 3 other sets of corresponding angles. We'll get into that as well. Alternate interior angles. Of course, they have to be interior. So let's just identify one of the interiors, and then we'll find its alternate interior. In fact, I'm gonna see if it'll let me do, there we go. Oh, I got to do that. That's pretty. I'll mark this angle. I'm looking at this one right here, okay? So it's interior, right? First off, we know it's interior, but now it needs to alternate. So just like it was with alternate exterior angles, if it alternates, this one I would say is on the left of that interior at that intersection. So the next one needs to be on the right of the interior. That'd be like, let's see if this works. This one right here. Try to make that smaller. That other red one right there, okay? Those are alternate interior angle relationship right there. Alternate interior angles, they need to be at different intersections as well, just like alternate exterior angles do as well. In this diagram, there is another set of alternate interior angles. We'll look at that in a different example though. So next up, we got straight angles or linear pairs. Again, it's just any two angles that make up a straight line, right? So I just need to find any straight line on this. I haven't used this angle yet, so, well, I'll use the exterior so it kind of matches in green. Not that it's exterior or that it has to be exterior. But I'd say this angle right here, it can be straight angles with this one right here. Let's see if I can mark this one okay. This one, all right? So again, I'll mark it in green. Give it a different marking so we know it's different though. So those two are straight angles, and you could say, some of you would say, well, why not just make it this one? You could, and that'd be straight angle pairs as well, but I chose this one. And then finally, vertical angles. We've done plenty of those. Hopefully we got that down pretty good now. So you can identify any of the angles that are on this chart here. I'm gonna do this one because it has been marked. And it would be vertical, which means it has to be through that vertex, such as where I've marked for that alternate interior angle, those two. Those two are vertical, they're through the vertex. And yeah, even though some of these other relationships are not congruent or equal, these two are. Vertical angles are always the same. So that gives us a head start on some of these other problems. This one we're assuming that line L is the transversal with relationship to lines J and K. If I said line J was the transversal, then I may have to rethink which ones are interior and which ones are exterior. All right, so I'm just gonna mark these. I'm gonna try to color code these, make it look pretty. So that usually means I wouldn't use blue. We'll see if I have to though. So alternate exterior angles. And we're just identifying alternate exterior angles. So let's see if we can color code these, okay? So remember, it's gotta be on the exterior. So just identifying interior and exterior first. So here's my interior first, and then I got my exterior. Of course, this would be considered on the outside. Now looking at like this means that I'm looking at line L as the transversal. I forgot my E. All right, so I need at least exterior relationships, but they need to be alternating. So if I look first at this angle, I'd say, okay, this one's in the top right. So alternating would be bottom left. It's kind of opposite right there. So those two blue angles are alternate exterior angles. Let's do the next one in red. So that'd be this angle. Now I would say that's top left for exterior. So the alternate exterior angle would be bottom right. This one. Now what about this one? Okay, I'm not going to write exterior and interior for just in the future, but we'll identify it. Interior, I'd say, on the inside, it's like a sandwich that's, I don't know, stacked or set up like this. I don't know. This is interior. I'd say these two are exterior. So I'd say, hey, let's look at this exterior angle. I'd say that's top right. So I'd look at bottom left. This one is alternate exterior with it. So right now, just right now, alternate exterior angles, interior angles, corresponding angles. Vertical angles are always the same. And also, well, linear angles as well. But none of those have to be the same right now, except for vertical angles. We will find a relationship where they are the same, though, and that's coming very soon. So the other exterior angle, of course, would be this one. It would be alternate exterior with this one. So I'd say that's top left and bottom right. Boom, there we go. So alternate interior angles. Again, these are the same graph. So interior, and then we got the two exterior parts. Interior here, these are exteriors. But we want interior angles that alternate. So I'd say, okay, let's look at this alternate interior. So you could say bottom right on this intersection, but it should be interior. So the other alternate interior angle would be top left on the other intersection. Again, these can't be at the same intersection. So the other alternate interior angle is this red one with this other red angle. Or for this other diagram, I have this interior angle. Alternate interior with it would be this one. But again, see how they alternate, right? This one's top right in this intersection, bottom left in the other one. Or this one's interior, I'd say that's top right at that intersection, so it's top left in that first intersection, bottom right in the second one. Those are alternate interior angle relationships. They're color-coded, hopefully that helps. All right, corresponding angle pairs. So there's lots of corresponding angle relationships. It's just they're in the same position now, right? Alternate means they're at different intersections, but, well, alternating, kind of opposite. Corresponding means they're in the same position of different intersections. So this one, if I said that's top left, I'd go to the other intersection, boom, top left. Those are corresponding angles. Continuing with the color coding, of course, I'd say, well, what about the top right? Well, it would be corresponding with the other top right angle. Or if I said bottom left, it would be corresponding with the other bottom left. Or bottom right with bottom right, those are also corresponding. So in this other diagram, we have the same idea. We could say, well, bottom right with bottom right, those correspond. Bottom left with bottom left, they correspond. Top right with top right, those are corresponding angle pairs. And then top left with top left, corresponding. What that means, since those don't have to be the same, it just means that you can have those relationships, but they are not always the same exact value. Eventually they will be, but that's a special relationship that's coming. So vertical angles, they're just through the vertex. Now these ones have to be at the same intersection though. So I'd say this angle here and this angle are vertical because it's through the vertex. Or this angle with this angle because, again, it's through the vertex right there. Or these two purple angles, or these two green ones. Those are vertical. Or these two orange ones, or these two green ones, or these two purple ones, or these two red ones. Those are all vertical angle relationships because they're through the vertex or intersection. Now, vertical angles, we know these ones are congruent, which means they are the same. Straight angle pairs, again, there's lots of them, but like this angle and this angle, that'd be a straight angle relationship. I'm only gonna identify a couple at a time though. So this angle with this angle, that'd be a straight angle relationship. Again, it's just that these two angles together make a straight line, and the red ones would make that straight line, and purple ones would make this one. So the green one, we'll say this angle with this angle, and again, that makes this straight line. Or an orange, looks like I haven't done this one yet. This one with this one, which then makes this line. So, and of course, it could make different lines depending on which one you pair it with. But it just needs to make a straight line with some other angle or sets of angles. So here's some angles that they've given us, some pairs of angles. We just got to determine if the relationship is alternate exterior, alternate interior, corresponding, vertical, or straight angles. Okay, so let's start with angles 1 and 8. Let's identify where they are first, 1 and 8 right here. Now, when we do this, one of the mistakes that students make is they kind of forget to kind of ignore the rest of this. So what that means is I'm not really considering any of the rest of the chart. I would just be looking at it like this. And if we saw something like this, we can see that these two are on the exterior, and they're also on opposite parts of the exterior. So that's alternate exterior. There we go, alternate exterior angles. 12 and 11. Let's identify 12 and 11. There's 12, there's 11. Now since they're right next to each other, they make up this straight line right there. So that is a straight angles. So 13 and 21, let's identify 13, 21. We see those are on the same side of that line T. They're in the same position of different intersections, right? I'd say that's like top, and this one's the top as well. So those are corresponding angles. And then 14 and 15, here and here, these are through the vertex, which means they are vertical angles. And that also means that they'd be the same as well. And then 7 and 14, 7 in orange there. Where's 14? Right here. Yeah, again, this would be, I'd just be looking at these two lines with this transversal. Those are on the interior, and they're opposite, so they are alternate interior angles. So next up, we got 9 and 20. Here's 9, here's 20. Again, we're ignoring all the rest of those lines. So while this may not look like it is, these are both on the exterior, and they're on opposite parts, so this would be alternate exterior angles. And then 5 and 7. Here's angle 5, here's angle 7. That's a linear angle relationship, or straight angles. And then 22 and 23. Yeah, we've seen that before. Those are vertical angles because they're through the vertex. And then angles 1 and 5, there's angle 1, there's angle 5. Those are at different intersections. And I'd say those are both at the top of those, so those are both corresponding angles. And then finally, 21 here, here, and here. And again, we do have that line in the middle, line R, but we're ignoring line R, which means that these are both on the interior, and they're opposite of each other, so that's alternate interior angles. There we go. All right, so there's that objective. But we have another part to this, right? I can use angle relationships to solve for missing angles and values. But that's the thing with the vocabulary. You have to know the vocabulary before you can move into this part, okay? As long as you understand the vocabulary, you can do this stuff pretty quick because, well, as long as you can figure out the vocabulary and solve equations, just one variable equations, then this goes usually pretty quick. So here's some angles. It said number these 1 through 8, which we did. Now we have the angle relationships, okay? Now the other thing they said on this one is lines L and M, there we go, lines L and M are parallel. Now if they are parallel, then all the relationships that we just went over, except linear pairs, they're not guaranteed to be the same, but alternate interior angles, alternate exterior angles, and corresponding angles, if the two lines the transversal goes through, those two lines are parallel, those three angle relationships are automatically going to be congruent or the same. Now, that also means, vertical angles are always going to be the same, but vertical angles aren't at different intersections, which is the unique thing on that, okay? So here's a picture. A transversal can intersect two lines, but we are now particularly interested in transversals that intersect parallel lines. That's true. So what type of angle pair is 2 and 6? I'm not going to copy those, but... All right, angles 2 and 6. As long as we've drawn these vertical, or parallel rather. Angles 2 and 6, let's identify those. 2 and 6, that's this one and this one. Those are corresponding angles, okay? I suppose I can do this fairly quickly, but this would be angle 2, and if I'd drawn it better, this would work better, but hopefully it won't matter. And then we got angle 6, like this. So let's take angle 2. Let's see if it'll let me grab it. What we should notice between these two angles, if I was able to move it, like if I were to just move this down, we'd see that it's the exact same angle, which is part of the objective here, is when the two lines are parallel, those angle relationships become congruent or the same. And it would hold true for not just corresponding angles like 2 and 6, but alternate interior angles and alternate exterior angles. So when we see those relationships and parallel lines, then we know that the angles are the same, which allows us then to solve for, well, sometimes it'll give us an x value that we have to solve for, but it then can allow us to solve for missing angles as well. This is pairs of vertical angles. What do we know about vertical angles? They're the same. Now, I don't think we've gone over this yet, but there's a symbol for congruence. That's this one right here. Two equals, it's an equal sign with just a little Enye symbol. I don't know what it's actually called, but it goes right above it. It just means that the two angles are the same. So let's just list a couple of vertical angles like angles 1 and angle 4. These would be vertical, which means they're also congruent like this. And that's how that would read. Angle 1 is congruent with angle 4. But also, you could say that, for example, angle 7 and angle 6 are vertical, which also makes them congruent. We're not going to worry about the rigid motions because it's just not working on this right now. Yeah, there were more vertical angles, but again, they're all congruent. So, if two parallel lines are intersected by a transversal, corresponding angles are blank, alternate interior angles are blank, and alternate exterior angles are blank. The blank we want on this one is congruent, and that's for all three of them. Congruent, which means, again, that they are all the same. Now, that doesn't mean corresponding angles are congruent with alternate interior angles or exterior angles. It just means that the corresponding angle pair is congruent. So if we know that, and we say lines L and M are parallel, which it does say right here, L and M are parallel, then we know that the angle relationships are congruent or the same. So right here, where we see this 110 degree angle, I don't know why, but my first instinct was just to look at angle 8. Those are corresponding angles. And since the two lines are parallel, that means they're the exact same. So I'd say angle 8, also 110 degrees. All right, and then I could say, well, angle 8, if I know that's 110 degrees, then its vertical angle would be the same, right? That's angle 5. So that angle 5 is also 110 degrees, see that? Or even that angle 1, which was vertical with that 110 degree angle, that means it's the same as well, 110 degrees. Now you could say, well, angle 1 was alternate exterior with angle 8. That's true, which makes them the same. And since angle 1 was 110 degrees, its corresponding angle also is 110 degrees. Or this 110 degree is alternate interior with angle 5, so it still is 110 degrees. But what about, for example, let's look at angle 3 here, okay? Well, I see that angle 3 creates a linear pair with 110 degrees. So to solve for it, I could take 180 degrees, which is the straight line, straight angle, and subtract the one angle that was given, 110 degrees, and then I get angle 3 here at 70 degrees. So there's 70 degrees there, angle 3 is 70 degrees, and its alternate interior angle would be also 70 degrees here. That's angle 6. But its vertical angle, angle 2, is also 70 degrees. And so angle 2 and angle 7, which are alternate exteriors, since those two lines are parallel, angle 7 is also 70 degrees. So hopefully just from this one exercise, we see that relationship between alternate exterior, alternate interior, and corresponding angles. And when the lines are parallel, yeah, a lot of the times they're just the same anyways. But again, the thing that we need you to remember is that these are all parallel lines. In the first part of our exercises today, they were not parallel. And so we would not say that these relationships are the same. Now right here, going back to what we talked about last time, when you see this box as an angle mark, that's a 90-degree angle right there. So for part A, we can see the relationship between that 90-degree angle and this 2x plus 10. Since it said that L and M are parallel, we would say that these two angles that are showing, they're corresponding, so they're also the same. So I'd say, okay, since they're the same, that means 2x plus 10 would have to equal 90 degrees right there. And then I would just solve this equation for x. So I'd use principles of equality, subtract 10 from both sides to zero that out. 90 minus 10 is 80. This would equal to 2x. And then divide both sides by 2 to make that 1x, phantom 1. X now equals 80 divided by 2, boom, 40. So for the angle, we wouldn't need to solve for it. That's true. But it still wanted us to solve for the x. Now, the nice thing about knowing, like you're saying, we know this angle is 90 degrees, right? Because they're corresponding and the two lines are parallel. We would still need to solve for the x because it asked for the x value. And just check to make sure it works. 2 times 40 plus 10, yeah, that's 90. So yeah, there's two parts to this. We solve for x. And yeah, we knew from the relationship that the angle itself was 90 degrees. So on part B here, I have this angle, and line L and M are parallel. So we would say these two are alternate interior angles, which again makes these the same as well. So I'd say, 75 is going to, or the 11x minus 2, I just need to make it 75. And yes, again, we know that the angle itself is 75 degrees, but we need to solve for the x. So yeah, that is one of the answers. But let's solve for x, so I'd say, let's add 2 to both sides to zero out that negative 2. So 75 plus 2 is 77, which now equals, we'll drop the 11x, and then divide both sides by 11 to make that 1x. X now equals 77 divided by 11 is 7. So now we have that corresponding x value that goes with it too. So we have seen these types with the triangles, right? So they gave us some kind of angles, had to solve for a missing angle or some kind of exterior angle from those triangles as well. So we're going to do the same thing on these ones. We need to find the angle measure and then solve for x. And again, lines L and M are parallel. That's very convenient. Now these ones did not give us the angle measure, which means that we have to solve for x first. Now the interesting thing about these two angles that we're given, these are alternate exterior angles, which means that they should be equal. So I'd have the 12x plus 17, that angle is going to equal the other angle, 14x minus 1. And now we're just using principles of equality to solve this thing. I'm going to keep my x's on the left and the numbers on the right, not that it matters. But that means I'd have to zero out that positive 17, so we'll subtract 17 from both sides. And also I can zero out the 14x, so we'll subtract 14x from both sides. So that zeroes these two out, which is what we would want. 12x minus 14x's, that's negative 2x's, which equals negative 1 minus 17, that's negative 18. And then solving for x, I'd divide both sides by the coefficient of x, negative 2. That's 1x now. Negative 18 divided by negative 2 is positive 9. So I have the x value, and that's good. But we need the degree angles, the angles in degrees, right? The measures of the angles. So I'd say 14x minus 1. I'll start with this one. But now x is 9, so I got 14 times 9 minus 1. So that'd be 92, 26. Minus 1. Seems like it'd be 225. I feel like I should use my calculator just to make sure. 14 times 9 minus 1. Boom. 125. Yeah, I was up. I carried over too many. So this angle would be 125 degrees. Now, the other one should be the same if I replace the x with 9. So I'm just going to plug that into the calculator. 12 times 9 plus 17. Boom, 125. So it also shows that it's the same, which means we did it correct. These two angles are 125 degrees. All right, for this one, let's just identify the relationship between these two angles. We got this angle here. It's on the interior, though, of those two parallel lines, and then this one's on the exterior. So they definitely can't be alternate interior or exterior angles. But we do notice that they're in the same position of different intersections, right? They're in the bottom right of both intersections. So that means they're corresponding. And since we know lines L and M are parallel, that means they're the same. So when we set up this equation to solve for x, we can then solve for the angle measurement of both. So the first angle there, 21x plus 5. And this should equal 23x minus 5. Like this. And yeah, still using principles of equality. I'll keep my x's on the left and just the numbers on the right. So I would subtract the 5 from both sides, while simultaneously subtracting the 23x from both sides to zero both of them out. Yeah, and we can see 5 minus 5 is 0. 23x's minus 23x's is 0. So now we got 21x's minus 23x's. That's negative 2x's. This equals negative 5 minus 5, which is negative 10. Last thing I need to do here is divide both sides by the coefficient of x, which is negative 2. That becomes a phantom 1, x. And negative 10 divided by negative 2 is 5. So x is 5, and that's our first answer. But then I just need to solve both of these, right? So like this first angle, I'd say, well, 21 times 5 plus 5. Because now x is 5 here. So 21 times 5, that's 105, plus 5, that should be 110 degrees there. And we'll just make sure the other one is true as well. I'll say 23 times 5 minus 5. What do we get on that then? So 23 times 5, that's 115, minus 5, that's 110 degrees as well. So we get the same angle measure for both, which we should, right? We said that they were equal. And now we've proven with this corresponding angles, because the lines were parallel, that these two are the same angle measure. So this one's saying, given two lines J and K and a picture below with transversal L, devise a strategy to determine whether the two lines are parallel using what we know about the properties of rigid motion. Not really rigid motion, just the angle relationships, really. Also, use your strategy to determine whether lines D and E are parallel, stating that the lines do not look parallel. It is not a justification. Well, what this means is that the three angle relationships that we've gone over, corresponding angles, alternate exterior angles, and alternate interior angles, in order for the lines to be parallel, they have to be the same. So we work one way, saying if the lines are parallel, then those relationships are equal. Now we're doing it backwards. We're saying if the angle relationships are equal, then the lines are parallel. If they're not equal, the lines are not parallel. So just an example of that, right? I'd look at these two alternate exterior angles, like this. If this one was 15 degrees, and this one was 110 degrees, then we could say these two lines are not parallel because these two alternate exterior angles are not the same. They have to be exactly the same for the two lines to be parallel. Properties of transversals to parallel lines. Complete the statement. Given two lines, if a transversal cuts through both lines so that corresponding angles are congruent, again, this is just backwards, then the two lines would be parallel. Right? Whereas before we were saying the lines were parallel first, and then we knew that they were congruent. Now we're saying if we just knew the angles were congruent, then we would know that the lines are parallel. It's just backwards. So we're just determining if the two, not the transversal, but the two lines that look like they're parallel actually are. So right here, first we need to identify the angle relationship, right? 110 and 110. Those two are alternate exterior angles. They are the same. So we would say that line P is parallel, and I'm just going to use a symbol for parallel. It's two lines like this to line Q. Some people make the lines like this. I think it looks too much like absolute values, but if you feel more comfortable doing that, that's fine. Or an 11. But when I slash them like this, then it's a little bit more clear that we're talking about parallelity. So this would read, line P is parallel to line Q. Line P is parallel to line Q. They may look different, but they mean the same thing. Now this one, a lot of students would look at this, in the past have looked at this one and said, hey, this one is not, these two lines are not parallel. But we won't know until we know the relationship first. And I see no relationship between the 86 degree and the 91 degrees right there. One's on the interior, one's on the exterior. They're not corresponding, so that doesn't work. They're not vertical even. So I need to find one that will relate to them. So I would find either this one or this one. So you could say corresponding or alternate exterior. I'll go with alternate exterior, not that it matters. So to find this angle, I know that these two angles make a straight angle pair. So that means that it add up to 180 degrees. And to find the green angle, I'll just subtract the one angle we know, 86 degrees, which then shows that this is 94 degrees in green. So that's 94 degrees. This other angle in green that I'm showing here is 91 degrees. They're not the same, but if lines M and N were parallel, it'd have to be the same, exactly the same. But since they're not, these two are not parallel. But yes, that would work if you took 91 and 86, knowing that the two would need to make a linear pair. That would work.